So this first value indicates the lowermost value in your R plane, the lowermost value in your G plane, lowermost value in your blue plane. Okay, so this indicates that these values, these lowermost values, be converted to these values in the individual planes. So if the original image has got the intensity level, these are all the normalized values. Usually the pixel values will be varying from 0 to 255, and when you normalize, they will be converted to a value between 0 to 1. So 0 indicates the black color, and 1 indicates the white color. So when it is in unnormalized mode, we say 0 is black and 255 is white. Okay, so when you normalize it here, so this 0.5 is in the midpoint, so I could say 0.7 is more closer to white and the 0.2 is more closer to black. Okay, so when you have such lower values here, all the lower values to 0.2, 0.3, 0.4, they are all actually getting converted to the lower values 0.3, 0.5 and 0.6. Okay, all values lesser than or equal to 0.2 will be converted to 0.3. Okay, and all the values in R plane or G plane, which is less than or equal to 0.3, will get converted to 0.5. All the pixel values less than or equal to 0.4 will get converted to 0.7. 0.6. Okay, so these are all the values which the user gives in. So accordingly, like this are all the higher values, highermost values. So greater than values 0.3, greater than or equal to 0.3 will get converted to 0.7. So this R plane intensity, which is 0.3, is just converted to 0.7. Okay, so when I do such kind of image adjustment, I could get the original image intensity getting varied. Okay, so if you adjust the intensities, the lowermost and highermost value intensities, accordingly you could play with the spatial domain. Image can be operated in two domains, either in spatial domain or in frequency domain. If you are working on directly with only the pixels, okay, if you are directly playing with only the pixel values, then it means that you are working on only the spatial domain. Okay. If you take on the Fourier transform or discrete cosine transform or wavelet transform, any type of transformation technique, as you know, generally with signal processing, you are converting the spatial domain pixels into its Fourier coefficients or wavelet coefficients. You know, we convert the pixels into its coefficients, and you know that the transform is going to be a reversible process. So if you are converting the pixels into its coefficients, and if the coefficients are not at all being altered with anything done in the frequency domain, directly from the coefficients you could get back the pixels. So whatever be the operations which we are discussing currently, and the earlier thing which I have talked, we are operating directly on the pixels. I'll say we are playing with the pixels. Okay, so you alter the pixels here, you alter the pixels there, you just make a transformation with trial and error, and we are just trying out in a way that the image appears better. Okay, so these are all called as point-to-point or piecewise linear operations or spatial domain operations which you are doing on the image. Okay, so these are all some very basic content of image.